Hello, welcome to another episode of Free Code Friday. My name is Jason Bach, and this is episode 22. And today, I'm not actually going to be doing any code. I've been doing this now for 21 episodes, and I've got a lot of ideas to keep doing more and more episodes like this in the future. So there's not a dearth of material that I could be just floundering on, not coming up with stuff. I actually really enjoy doing this, and it's fun. But I've been trying to think of things to keep on doing and to keep me occupied. And I actually haven't done a recording in about 3 months. Most of the material I've done before this was done in like 2 or 3 big chunks and just did them within a week or two. So I just haven't had the time or the focus to get back to this, but now I am. And what I'm going to be talking about today, hold on, need some coffee because it's in the morning right now. What I'm going to be talking about today are 2 projects that I want to focus on. I've been doing mostly my stuff with Rocks and Editor Config Generator, and I may hop back to those here and there. But I wanted to start doing 2 projects that I've been thinking about for quite a while, actually. And I said, if I don't ever just take that first step, I'm never going to make any progress on this. And thinking about it is fine, but without actually starting to produce something and starting to get into those technical problems and issues, it's just all going to be theory and drawings and discussions. So I want to actually get to this. So there's 2 things I'm going to be working on and doing some live coding in this channel with these 2 projects. So what are they? So let's PowerPoint this away. The first one is something that I'll explain who we is in a moment, but we're calling Ystari. It's interesting that trying to come up with a project name these days is ridiculous because the name has already been used in some way, shape, or form by somewhere else, and then you can actually run into copyright issues and trademarks and all this stuff, and it's stupid, really. Not stupid. It just feels stupid because it's so hard to find something that's unique and catchy and grabs your attention. I was actually looking at this tool called Pulumi, and I found out where the name actually came from, which it seems like it's a slight variation of the word broom in Hawaiian, and which is interesting because a couple of people that worked there when they started the company, they were from Microsoft or knew this guy that worked at Microsoft, Christopher Broom, I think his name was, and he passed away some time ago, and it's kind of out of respect for him that they named the company kind of after him. So I thought that was kind of cool because I never knew where they come up with Pulumi. Some people ask the company that I work for, why Magenic? That's just kind of a nonsense word. It's nothing that actually is a real word. And it actually comes up from the combination. Apparently, one of the owners of the company, Greg Frankenfield, said that it was a burst of creativity when he was on a flight because he had to come up with a new name for the company. Originally, it was called Logicon. And when we opened an office in San Francisco, there was a company called Logicon that was quite bigger than us, and we couldn't use the name, so we had to come up with something unique. And the story goes that it's a combination of imagination, genius, and logic. So parts of all those 3 words ends up becoming Magenic, which has been completely destroyed and screwed up by so many people. Magenta, Magenics, Magnetic, they never get it right. So it's naming is hard. Apparently, not just naming variables, but naming companies, naming frameworks, packages, modules, anything. It's not easy. So I even forget where the name Ystari comes from, and I'm still not quite sold on it, but it is what it is. We're going to stick with it for now. So what actually is this thing? In a nutshell, it's a modern distributed object framework for .NET developers. And so, okay, well, why modern? What does this mean? What can you give me more details? Sure. is essentially a evolution of CSLA. Now, what is CSLA? CSLA is this business object framework that was created by a guy named Rocky Lotka, who is the CTO at Magenic. And it's interesting because people seem to either have this kind of love-hate relationship with the framework. And some people swear by it and say it's great, awesome. People build apps on it, apps that actually are used in medical facilities and things like that. Some people I know just despise it, think it's the worst thing ever, and it's just junk. I tend to fall on there are good things about it. There are more good things about it than bad things, but there are also some things that at this point in time kind of drive me nuts. And to explain this a little bit, when I first joined Magenic, way back in November of 2000, been there a long time, I didn't know who Rocky was other than just by a face. I actually had bought his rocks book, where I got to give him crap for this, where he's doing the thinker pose with his hand on the chin, and bought his business object book or whatever it was called. And what grabbed my attention was he's actually using LSET. Somebody's using LSET for serialization and not .NET and just VB5 or whatever it was. Ooh, that's awesome. I don't know if I do. I don't even think I. I don't even think I have the book anymore. I was looking at one of my shelves over here at the books that I have. I don't even think I have that copy anymore. But it was an interesting idea. Didn't really do much with it. And then when I joined Magenic, I realized he had actually joined the company just a short time before I did, but didn't actually end up talking to him that much. And then I think around 2002 or 2003, somewhere in there, I can't remember the exact date, but there was a presentation he was going to do internally at Magenic on this new CSLA.NET framework. And I still remember one of the first slides he showed was one of the CSLA data portal operations that they had to be named data portal _ fetch or child _ create. And I said, that's stupid. That feels like VB. That feels like I'm making an event. The naming is, of all things for me to complain about. Again, that's 16 years ago. I think I would hope that my maturity has gotten a little better since then. But something about that just felt wrong from a naming perspective. Why did I have to name these things this way? And in fact, this is an idea that I want to change in Ystari. But I didn't use the framework on projects I was on for a while. Magenic didn't push it, but it was something that, because, hey, it's Rocky, he's got this framework, it's supposed to make development faster. It sometimes is used on projects. I didn't until about 2008. And then I got on a project that was using WPF, and I started to see some of the good things about CSLA in terms of encapsulating, for lack of a better term, business knowledge, rules, different kinds of rules, validation rules, authorization rules, and having them work in concert with a front end, which in this case was WPF. That's also what started to make me go, binding is actually not a bad thing. Up until that point, I thought binding was stupid and it sucked, because the only experience I ever had with binding was in like VB and WinForms, and it just felt kind of Whereas in WPF, something maybe switch and go, this is actually powerful. And doing MVVM and actually having a rich model, which was the business objects that we were creating, things actually started to turn in my head about this framework. And I started seeing the power and the benefits of it. At the same time, there were things about it too that were starting to drive me nuts. One was dependency injection. It really had no sense or idea of it. This is something that kind of was addressed a while back. Rocky and I actually talked about a way to add it in, but it felt kind of bolted on. It works, but it's not a native core part of the design, for lack of a better phrase. And it's not the best in terms of unit testing, which is another part of CSLA I don't like. CSLA relies upon a lot of things that are statics. And if you set those up for a unit test, you can't run your unit tests in parallel because, for example, if I set up ways for my dependencies to be injected into a CSLA object, that's in some static property, I forget where in CSLA. But then if I ran two tests in parallel and I had my dependencies set up for both tests, one could clobber the other. And you can't run them in isolation. You can't test, well, you can, that's something also that got changed, but you can't easily test object graphs in isolation. So if I have a root object that has a list of child objects, and those child objects also have references to other child objects, and I want to test this one, I can't just test that one in isolation very easily because it's going to be making the whole graph, and that became pretty hard to do from a testing standpoint. It ended up having these tests that were very heavyweight in terms of this one is essentially testing everything in the object graph and all of its dependencies, and that just didn't feel right to me as well. So these and other reasons started to make me go, I think there are ideas in CSLA that I actually really do like. I think there are benefits. The notion of having domain logic, and I'm going to get away from using the term business because business just feels enterprisey and stuffy, and I just don't. I'm going to call them domain objects, and that's also a little risky because people will go, oh, are you going down the DDD path? And that's not the intent either. Not that there's anything wrong with that. It's just I want to use a word that I think is more encompassing to other environments, other areas. And when you just say business, it feels like this is an app that isn't really, it can be exciting, but I just want to use something that's could be used anywhere. It's just trying to codify a domain. I have a timesheet, I have a customer, I have an entity, I have a loudspeaker, whatever you're trying to model in whatever application you're building, that you could use Ystari to do this, but do it in a more modern way. Okay, so what does that mean? I think I kind of already talked about some of these things, is that there's no real notion of handling dependencies. There is. It's this iData Portal Activator. I wrote an article about this on CSLA on Magenic site a couple of years ago, but it doesn't work. What's interesting about CSLA 2 is that when you start adding dependencies into these objects that can actually be mobile and go across literally different machine contexts, what do you do with your dependencies? You can't just say, well, I had a connection to a service or to a database given to me to load data, but now my object's actually going to be loaded into a client, like a UI. You can't serialize that over. You don't want to either, but maybe there are some things that you do. So I was at a client a couple years ago, and that case actually started coming up. How do we actually have dependencies that are just injected client side and not server side? So those cases can happen. The vast majority of cases where you're doing dependency injection assumes that the target is at rest. It's not going to move from the actual execution context that it's in. So for example, if you inject a dependency into a controller in ASP.NET, that controller is not going to go anywhere. It's going to be on that machine or whatever environment you have that controller hosted in. CSLA-based objects, they may not, and it depends on how you configure it, but they could move, and so you have to be careful with that. So that's another twist to all this. Has a lot of statics. I already talked about that. CSLA has been around too for a long time, and it's interesting that it's been targeted for a lot of different environments and has been used a lot. Used a lot of different frameworks like a remoting, workflow, Silverlight, but those things are long gone for the vast majority of people. I haven't heard remoting being used at any client for I don't know how many years. So, and Silverlight is effectively just a done thing. So effectively it is, it's just now it's in that as applications that did target it, they're eventually just going to go away. So, but CSLA did target these things. It was actually good for CSLA to target Silverlight because that got it into the mode of being able to target different platforms, different environments, where CSLA can actually target many. The whole .NET Standard thing, Rocky had to struggle a lot before that for years making sure it worked on iOS and Android and Silverlight and all these other environments. But these things go away. So in some ways, doing a reboot can give you a fresh start on stuff. Think of .NET Core; it's essentially the same thing in the large, but re-architected, re-engineered, much faster, much cleaner, much better. Okay, so that's why me and another guy, we've been talking about what can we do to make CSLA better, and that's what we're trying to do with Ystari. Is just this idea of what can we move into making. What can we do that's just a clean room environment and make this a little nicer, a little easier to work with? So the idea and the goals, and again, if you go to this site, you can look at more of the documents and some of the markdown documents I've been putting together. Some of the ideas is it's going to target at least .NET Standard 2.0, although there's work now for 2.1. But the point is that that's what it's going to target. So any platform, any framework that supports 2.0, this will work in. Want to make sure the serialization is very fast. There's a custom serialization engine in CSLA, and we might just use that and expand upon it. Or maybe we use, because I know there's things like Protobuf, there's other serialization engines out there that are more modern that we might use. So that's just kind of this, let's just make it better. About a year or two ago, I actually looked at the serialization in CSLA, and the design of it is kind of turned my head around. It felt like there was like statics calling instances, calling other statics, and it was really kind of hard to figure out what this all did. But once I got to it, I realized there was a point where I could say, you know what, you can actually change this a little bit, and I think I was able to shave off about 10% in the size of the stream and make it about 5 or 10%. I remember it wasn't like a huge jump, but there was some improvements I made on it. But I really want to look at things like span of T, pipelines, other optimizations that are in modern .NET applications, and see if we can make this blazingly fast for serialization. The notion of stereotypes, if you know CSLA, there's like iRead-only base, iBusiness base, I forget all of them, but there's like 6 or 7. And they probably will still exist, but I don't want to be so reliant upon inheritance. We have this idea of maybe a stereotype is built upon a composition of other things, other classes that are injected into that stereotype, and that way things are more composable rather than being based on inheritance. So again, this is just an idea. We may or not do this, but I think it's at least worth investigating and trying it and see what it would be. All operations are going to be asynchronous. Asynchronous was kind of bolted on and added on in CSLA after the fact, just like it was for a lot of frameworks, because async await wasn't really, in fact, it wasn't a thing until C#5. And while there were definitely ways to do asynchronous development before that, it really never landed in .NET until that release of C# and then whatever VB. But and F# had its own stuff, which is cool. But in C#5, that was when it finally landed. And of course, trying to retrofit that in, there's cases that we found. There's like one case if your client is async, but your operation is sync on CSLA or vice versa. There's like there's a table of 4 decisions. If your client is sync or async and your operation is sync or async, one of them can actually lead to a lock, and the application locks up. So we decided all operations are going to be asynchronous. If you actually have an operation that is synchronous, you would just return complete a task or from result on a task. And that way the model is very consistent. Most things we feel that would be on, again, we as Rocky and I and a couple of other people that have talked about this, feel that the vast majority of operations, when you're creating fetching objects, inserting them, updating them, whatever, will be asynchronous operations. So that's what it's going to be targeted as. Operations will be registered. Again, you can look on the docs if you want to see what we mean by that. But instead of having this well-known name that you have to pass in, and then this notion of criteria objects or how many arguments can I pass in, we have a design to make that much clearer. At least it's somewhat opinionated, but a way to actually use tuples. Tuples are this small thing that got added in C#7, but oh my God, they can be used in so many creative ways. And we're thinking of actually saying for operations that you could pass in, arguments, values as a tuple, and then you can also say another tuple that says here are all my dependencies, and Ystari would just make that work, but then it's all safe, it's all type safe, and you don't have to actually have a specific name for these operations. You can call them whatever you want. It's just that you register them once, and by how you register the action of the func or whatever you're going to do, that's what determines the name of the method. So more flexibility there. To the point of dependency injection, it will be a first-class citizen. It's going to be baked into the framework, very composable, very unit testable. Can't do constructor injection just because of the fact that the notion that these are distributed objects, they can move across contexts. Doing them within a constructor is hard because typically serialization engines don't understand if I have a constructor that has all these arguments, how do I get them passed in? So, and again, I can be proven wrong. Maybe we actually do build that in this time around, but we're thinking no, that would still not be the case. But as I mentioned before, there's a way that we're thinking that with these operations that you can easily say, here are all the dependencies I need, and those will get injected into those operations. The rules won't change much. We're thinking though, a friend of mine we've talked a lot about Ystari, he created this concept of fluent rules based on what's currently there in CSLA. So we may put that in as something that's just native to the framework. We're also going to, right now in CSLA, there's this add business rules and then add authorization rules or something like that. And one is a virtual method and one is a static. And what it really comes down to is CSLA will look at a business object and say, do you have add business rules overridden? And if you do, calls it once per type. So it's really a static. It just feels like an instance method. And the fact of the matter is rules are based on the type of the object, not the actual instance. So we're just going to say, hey, mark a static method with rules, and then you register all of your rules there. So we think that's a much cleaner design. It's at least much more apparent as to what's going on and what's happening. So, but the actual rules themselves, the way they're designed and architected, we don't think will change much. Maybe asynchronous, because the way asynchronous rules work are not quite the same thing. But if you start mixing modalities here with async and sync, becomes a little tougher. So, but that's something that we're looking at to say, maybe we can make asynchronous rules even cleaner. Properties, we don't think will change much. There's this whole notion of property infos and how property registrations work so that CSLA works well with binding environments and whatever. We don't think those are going to be changed. There is one thing that I want to look at: property behaviors. I've run into the case where I want to know what the previous value was of a property before it got changed. The default behavior is it only keeps the last one that you did. And so you could end up getting to the original value, which then really means it's not changed. But because of the way you've gone through your state, CSLA doesn't know what the original value was anymore, so it still thinks it's changed. And doing things like that with strings can be kind of an overhead. So maybe you want to use hash code values of strings so that you're not actually keeping the original copy of the string, which might be thousands of characters long. So maybe doing some things with those behaviors and making that cleaner and easier to do. That was a little difficult and still kind of is. Remove all static and global information. Trying to look up for identity, application context, all this stuff. Really, arguably doesn't even need to be in CSLA Ystari directly. Those should be things like dependencies, and so make those fit into the same kind of model, same kind of idea. Make it work with what really is becoming the standard for applications to register, start up, configure things. We want to fall into the same world as that. Okay? So, what won't carry over, we have no plans of doing the factory approach if you know CSLA and how it can do this kind of, how does the object instantiate itself and initialize itself, or is that done outside the object? We think it should be done with the former. The second one can be done the first way if you want it to be. So rather than trying to have two different ways of handling the lifetime of a business or domain object, we're going to just say one and just leave it at that. So that's not going to happen. End level undo, don't really see a need for that to be added. Some people may like that, but yeah, we don't really see a need to have that kind of functionality there. It's not really that big of a deal anymore. And there's going to be no migration of porting. So if you are using CSLA and you look at this and go, hey, I want to use this, there's no just migrate or port over. This is a whole new framework based on the spirit and the ideas that are in CSLA, but not a direct port and saying you can just take this and move it over. You'd have to do some gyrations probably to do this. So that's the intent of Ystari, and that's what one of the projects I want to work on here. And I'm going to be looking to do as like a test project with this is rebuilding my website, which has kind of fallen off the wayside in the last couple of years, and revitalize it, rebuild it using things that are based in Ystari, and also building it on top of Blazor. So I think that would exercise a fair amount of cases. So that's the kind of eventual test goal, to have it in a real app to see how it works. The other thing is more of a fun project. This is called Dub Sharp. What the heck is Dub Sharp? So Dub Sharp actually is for when the W is for whenever. And so Dub Sharp is essentially a compiler I'm going to write in C# for whenever. What is whenever? Whenever is a esoteric programming language, and there's many of these esoteric programming languages that are silly, fun, weird, odd kind of languages. There's one called Bifunge that I've written a interpreter for called Iron Bifunge, because dynamic languages and .NET all should start with iron apparently. But I never actually have written a compiler per se, and I've been interested in just trying it. What does it take? How can you do it? And I don't want to get into a full-blown language like C# or like Ruby or anything like that, trying to write a compiler for those out of the gate. Let's take some baby steps here. And so this one I think might be interesting to try. And so what is whenever? So this is the statement from the site that talks about what whenever is. Is that really helpful? I'm not really sure. I also say that the first one there is interesting because you can randomly, in fact you randomly run different lines of code in your whenever program. So there is no sense of it, just like C# typically goes from top to bottom, more or less. But it just randomly will pick a line of code and say run it. There's no variables, there's no data structures, so it's kind of a silly language, but it's kind of fun. This is how it works. So you can think of whenever as having a bunch of lines, a bunch of statements that are put into a grab bag, and then the engine just randomly picks a line from the grab bag and executes it. Okay. So something like this, where each line has to be given an identifier 1, 2, and 3. This would just print hello to the console window. This one for number 2, this basically says if line 1 exists in the bag currently, add 2 more instances of it. And line 3 says if line 1 exists, take away one of the instances. And when you execute a line in whenever, it goes away. So depending upon the order of how these are picked, can change the behavior. And in fact, I'm going to actually have to run the slide here. I noticed in OBS that this doesn't actually just project it. It's going to keep my face there and you're going to see it, but whatever. It will help to actually run this to see what the differences of execution are. So just focus on the left side of what this is doing, because the next animation is going to give you a hint. So let's say that in this execution, line 3 was picked. So it says, do you have a line 1? Yes, you do. So take one instance of it away. So that goes away. And since I executed 3, that goes away. So the next line that could be picked is only 2. Does line 1 exist? No, so it doesn't matter. And you executed 2, that goes away. So nothing happened. Okay. But let's say that in this case, 2 is picked. So now you need to add 2 more instances of line 1. and then 2 goes away. I pick 3. Well, I'm going to take one of those away, doesn't matter which one, and 3 goes away. So the only things I have left are to print hello twice. So in this case, the behavior is different. Okay. And there's other things you can do in whenever. There's functions like defer, which says defer if this is true. Okay, so don't execute this. Again, basically says keep a statement around. And tells you the number of lines specified by X, and there's U of X. Okay, so you can actually run, you can do, if you're careful, you can actually have code that does something in a predictable way. It's just its execution time will not be predictable because you don't know. This will actually print, if you reason about what it's doing here, it will actually print out 99 bottles of beer on the wall. Okay, because the defers on all those first 3 lines will say if 4 exists, then defer the execution of the statement. Or if the number of lines for 1 is less than 2 and the number of lines for 2 is less than 3. Okay, so if you follow this a little bit, you'll see that nothing happens until line 4 gets executed. Because then that adds another 98 instances of the other 3 lines. 4 goes away, and so now you only have 1, 2, and 3. And so no matter which instance of 1, 2, or 3 picks, it won't actually print something until 1 gets picked first. And then it will go away, and then it will find the case where a 2 gets executed and a 3 and then another 1. And so with these defers and the number of lines and this Boolean logic, you can actually get programs to behave in the same way. They just won't execute the same way. Okay. And you can actually, I've never reasoned this one through. This is kind of why I want to build a compiler for this, because I don't know what this would do. I have no clue. And the spec for the language, calling it a spec is kind of a stretch, is, you know, how do some of these things actually work is not quite clear to me at times. So so it should be interesting to build a compiler for this. Okay, so we need to also represent line counts intelligently. If you go look at the site, it will say if you do something like a program that just says that one line of code, 1 #9, you're essentially adding 9 lines of code. So it'll say you'll accumulate too much memory. But if you're smart and you actually keep a line count with each line, rather than have physical line representations added or removed from your bag, you could go on for quite a while. Your count of lines could actually be a big integer if you really wanted. And I said, even if you use the unsigned long and you incremented it 5 billion times a second, it would take 117 years to overflow. So, you know, that might be, you know, maybe I have a compiler switch to say, somewhere to say, you know, like a count is actually represented by a big integer rather than a U long. I don't know. But that when I saw that, the thing about the memory, I was like, no, you just keep a count around. That's fine. Okay, so how am I going to build this? The thing about targeting 2.0 that was a little worrisome is how do you actually emit code? How do you get code emitted? Because reflection emit wasn't necessarily there. So I thought maybe just target 2.1 for now. System reflection metadata, I think, is another way that you can do assembly reading and assembly writing. So that might be something I can use. There's a Java example. I might just say nah at this point. I'm not really going to think about translating that to look at things and like how does a behavior actually work. But there's no real, this is the standard to make stuff work. So, but mostly about the emission of code. How do I actually get things that are executable? Though I heard that system reflection emit is actually going to be in .NET Standard 2.1, I think. So that might be a usable thing as well. Though system reflection metadata I've heard is interesting, so I might do it that way. Another idea I had is just say, well, look at what's in whenever and map the concepts to something like in C#. And so this would allow me to use the C# compiler API. Okay, so for example, if I had a 1#3, there really is calling some function called update line count where you give the line number and then how much you're counting. The defer 2, 3 is basically if not defer, then update the line count for 3 to just 1 by default. And then update the line count for 1 to -1 because you have to take that away. And in fact, that actually should be in the previous one. You should update the line count to the one that you're on, always remove at least one of them. Okay, but the point is to take what's there and map it into C# like syntax. And then I could actually just use the C# compiler to parse all that. But I don't know if that's going to make things for debugging. I want to actually be able to debug a whenever program. And if I do it this way, things may not map in how you debug into your program. So I don't know, maybe doing something like this could possibly work, but I'm not really hot on this, especially since the thing of the point about I've never done a compiler. So how the hell do I do this? There's a guy by the name of Imo. I'm sorry if I'm screwing up his name. He's actually doing a series of videos on YouTube now called Let's Build a Compiler. And so he's doing this language called Minsk, which looks kind of C-like or JavaScript-like, and showing how do you actually start building support for, to build a compiler for a language like that. How do you do variables? How do you do operators? How do you eventually probably going to get to how do I call a function? How do I parse all this out, Lexer's parsers and stuff like that. And so I'm probably just going to steal a lot from what he did, at least to build my own stuff. And so it's been educational to watch his videos and learn something from them. So that's kind of the idea. There's also this thing called crafting interpreters, which has been a really interesting series of articles. It's eventually going to be a book as far as I can tell. So that's also another good reference that I'm going to be using, but probably going down the road of let's parse these lines as they are, build and emit an actual assembly, have that execute, and see if we can get that to work. And the goal here is that in January, so it's October right now, in January, I'm going to be speaking at CodeMash in Sandusky, Ohio, at the Kalahari, and one of my talks is on esoteric programming languages. So I want to have a version of Dubsharp ready to go so I can show, hopefully that I can show 99 bottles of beer on the wall executing and debugging. That's the goal. And I don't have a lot of time, and I've got a lot of other things to do. I have VS Live Orlando, which is in early December, and I've got to get that going. So I have a lot of time after that to button some stuff up. So, but that's the goal. I want to have that as the target, to at least have something up and ready to go. So those are two projects that I want to start doing as videos and start building and doing live coding videos for Free Code Friday. I'm pretty excited about this. I think this is going to be interesting to see me kind of fall on my face and go, I don't know what I'm doing with some of these things in both Ystari and Dubsharp, but I think it'll be an educational and hopefully a fun experience. So that's all the time I've got. Thanks for watching. Leave any comments or questions down below. See you in the next episode.